Okay, so we're moving forward now with our panel session on career pathways and science policy. So this is one of the parts of the programs that I've really been looking forward to. We have three excellent speakers and panelists for us for whom we can pick their brains today. So I'm gonna introduce them in order that they're on the program, and as I do so, you can come on up and have a seat at our table here. Mics are on the chairs for you there. So first we have Robbie Barbero. From September 2012 to January 2017, Robbie worked in the White House Office of Science and Technology Policy, where he developed and implemented policy on a wide range of global and national life science issues, including the President's BRAIN Initiative, novel nutrient production platforms, genome editing, reducing the organ transplant wait list, student agriculture innovation and entrepreneurship, developing world cancer diagnostics, biotechnology regulatory policy, and federal R&D agency budgets. Is that it? And then what, you just gave up? Okay. Robbie is now the Chief Business Officer at Ceres Nanosciences. Robbie has an undergraduate and graduate degrees in biological engineering from Dartmouth and MIT. Our next panelist is Megan Houghton. Megan joined NSF in September 2015 as a AAAS Science and Technology Policy Fellow. She supports an array of emerging information science and engineering research frontiers, including smart and connected communities, as well as cross-agency, industry, and international partnerships. Megan is co-chair of the Networking and Information Technology Research and Development Program's Smart Cities and Communities Task Force and Executive Secretary for the Computer Science for All Interagency Working Group under the National Science and Technology Council's Committee on STEM Education. She earned her PhD in biomedical engineering with a designated emphasis in biotechnology at the University of California, Davis, and BE cum laude at Vanderbilt University, also in biomedical engineering. Next is Laura Pettish. Laura Pettish is the manager of the Coastal Communities Program in the National Oceanic and Atmospheric Administration Office for Coastal Management, and she works with the states and territories to address today's most pressing coastal issues and balance the demands of coastal resource use, economic development, and conservation. Laura also served for 3 years as the Assistant Director for Climate Adaptation and Ecosystems at the White House Office of Science and Technology Policy, where she led the Climate Resilience Team and the OSTP Resilience Portfolio under President Obama's Climate Action Plan. Laura received a BA in biology from Cornell University and a PhD in zoology from Oregon State University. Welcome very much to our panelists. Thank you for being here. Okay.
Do I need to do anything, or I'll just come up? Okay, well, I will, while we're waiting for it to come up. Can everybody hear me? Yes. All right. What about if I'm over here? Can you hear me? Yeah? All right, good. I'll stand right here. So I'm going to go quickly through my slides because I think the interactive discussion is going to be a lot more interesting, and these two also have lots of exciting things to say. But I want to impart on you, I think, a couple of points. One of them is that you don't have to work in a official policy position in order to be someone who's contributing to the science policy enterprise. And it's possible, there are many ways to contribute. So that's point number one. And number two is that if you are someone who is in search of impact and trying to make a difference in the world, there are a lot of different ways to do that. All right, so what I'll start with is my background. I'll give you 2 vignettes on things that I've done in my career and try to draw some connections between them. And then I will give you some advice because you asked for it. All right, so my career path. I think the theme in my career has 2 components to it. One is that I like to move every 5 years or so, like really change everything up and do something totally different. And 2 is that I look for places where I can surround myself with great people and work on projects that are going to be important and to which I can contribute. So after I finished my undergraduate degree, I worked for 3 small biotech companies. Was like absolutely sure I was not going to go to a PhD because I had no desire to do that. Did that for 5 years and then realized I really wanted to do a PhD. And so historically been valuable. So that started my mind thinking about it as an option. I did a bunch of other stuff while I was at MIT, but then when I finished, I cast a very wide net. One of the things I did was apply for the AAAS Science and Technology Policy Fellowship, and I was able to land a job to go straight into the White House out of that fellowship. So I finished up my PhD. My advisor was nice enough. I just had my second baby when I was defending, so she let me like postdoc in the lab for 6 months or so while we tried to figure out what it was like to have 2 kids, and while I was trying to figure out what my next job was going to be. Then I went to the White House and got to learn a lot about the federal role of coordinating R&D and how you can try to accomplish things, the influence of out authority stuff that was talked about earlier this morning, and try to make a difference in the space that I care about. And then about 18 months ago, so March of 2016, I knew that I wanted to make another change. I knew that the president that I was working for was no longer going to be president in a few months, and that I was going to want to go do something else, so I started looking around for my next job. I knew I didn't want to stay in government, regardless of who was going to win the election. And was really lucky to find a 13-person biotech startup that needed someone who could come in and both do, sort of the detail level product management on a product that we had, but also think strategically about where the organization wanted to go. And so that was a great fit for my success. Okay, so let me give you 2 vignettes. So the great news is a lot of this stuff has already been laid out by the speakers ahead of me, and I don't have to do it. But OSTP has these 2 primary responsibilities, and sometimes they overlap, but sometimes they're very similar to each other. This is a picture of the guy who was my boss, John Holdren, who was the president's science advisor, talking to the president. And so, my job as a staffer in the White House was to make sure that when this happened, that this guy knew the things that I knew, or that were in my space, so that when this guy asked the questions, he had the answers, right? So my job was not to sit at this table, right? I think that's one important thing to remember. Many people go to DC with the goal of like sitting in this seat, and if you happen to get the opportunity, you should do it by all means, but that shouldn't be the end-all be-all for you, right? The end-all be-all should be so that when this person is asking questions, that this person has the right answers, all right? Because the top priority in the White House is always serving the president, and, by proxy, the American people, because they selected that person to be there. So we saw some of this in the budget process slides, but I think it's really important for you to see this as well. This is a slide from Dr. Holdren, and the place of science in the White House is centered in the Office of Science and Technology Policy, but there are lots of other components in the White House. So each of these pieces of the White House has a director, and usually, almost always, they are a direct report to the president. So each of these people has somebody like a John Holdren feeding info into this central decision-making machine. And the president has his or own team of decision makers centered right in there, right? And then on top of that, all of these other components. So there are like 2,000 people that worked in the White House that I worked in. And in order for good decisions to be made and the right decisions to be made, just for the situation to be understood, it's rarely a single component in the White House who plays a role in there. And the responsibilities and expertise overlap. And frankly, there are scientists that sit in a lot of these other places sometimes. Most of them were in OSCP. Okay. So one thing that I will just caution you of, a lot of times people look at this and they're like, oh, this is crazy, it's too complicated, how does anything get done? Reminder, that's a feature of the system, not a bug, okay? So if you put yourself back 250 years ago when we were trying to figure out how we were going to, what we were going to do with this set of colonies that we had and build a more perfect union and those kind of things, the biggest thing that scared the founding fathers was, centralization of power and authority, right? And so they did checks and balances. announces and all of these things, wrote all of this into the Constitution. And this decentralized decision-making process, which is then reflected across all the federal departments and agencies and across Congress as well, was intentional. I don't think they imagined that there would be, there are 16 cabinet-level departments and 50 or so agencies that did R&D funding. They don't even think they thought the government was going to fund R&D, right? But the fact that it's so decentralized and disorganized, they probably would have been fine with. Because in general, the thing they were most worried about was a tyrant taking over and unilaterally making decisions. So it's super frustrating when you actually have a good idea and the system just won't adopt it, right? But that's because maybe your idea needs a little bit of tuning up or fixing or adjusting, right? Okay, so these are the examples of the kind of projects that I got to work on. And I only put these up here because I think it's a good reminder that if you can put yourself in the right place in the right organization, you can work on things that are important and have an impact. None of these I did all by myself, but they were all efforts that in some way or another I was able to contribute on or lead on. And I'm happy to talk about any of these, offline or afterwards if you have questions, both about the specifics of them or the process for how we got there. Okay, so the second vignette, serious nanosciences. So, how is it that I went from the largest organization ever created in the history of mankind, the United States federal government, to a 13-person startup company? Like I said before, I was looking for a place where I could have a good team and have an impact on the organization. It's a company that's been around for 8 years, but what they wanted someone who could come in and do some of that strategic thinking about where the organization could go. Also, the skill of being able to influence without authority is really important when you're a startup, because when you're in a startup, almost everybody in the world who can have an impact on your organization works outside of your organization. So you have to figure out what it is the world wants. What are you trying to get to the world? What are you going to do to make the world better? Who can stop you? Who can help you? Get out there, figure out how they think about the world, and then try to build your response in order to work in there. And to the extent that you can influence them as well, do that same thing. So a lot of the skills that I learned in the White House related to, and frankly, this goes back to just the kind of research that most of us do as well. Understanding complex systems, being able to tell the difference between a good idea and a bad idea, being able to tell something that's actionable and something that's not really useful in this space. So I won't. I'll just tell you what we get to do. That why I'm so excited about what I get to do is we have a technology that's very versatile. We make hydrogel particles that can capture and concentrate low abundance analytes from biological samples, and so we can improve detection limits of all sorts of tests and devices. And the challenge for a 13-person company is, okay, if you can do all of these things, how do you decide which one to do first and who to work with and how to do it? And that's where having an understanding of complex systems and being able to do opportunity spotting and see where momentum is building in areas is really useful. So this is advice that will be valuable to some fraction of you many years in the future, so hopefully somebody remembers it. But if you go do time in the policy world or in the federal government, and then you go try it, you're interested in going out into the private sector, and someone says, well, how is what you did in the government applicable to the private sector? Because there are many people who think that there is no overlap in those roles, even though Bill very nicely articulated this morning why it is a super important ecosystem for national economic security and the public good. The answer is that we live in a world of complexity and chaos, and organizing that complexity and chaos and identifying the places where the minimal amount of effort can lead to the maximum amount of leverage for the public good is important no matter where you are. All right, so advice. And I will all right, I first need to caveat all of this by saying that this is largely advice that I've stolen directly from my former boss and colleagues in the White House. But it's so good that I just keep it as a list for myself. Okay, so first of all, have a dent you want to make in the universe. This is Steve Jobs, right? But if you can figure out what that dent is you want to make, what's the thing you want to do that is a noticeable impact in the world, you're you're off to a good start. Be persistent. We used to call it water on stone. This is super valuable in the government, but also in academia and other places as well. Over time, even drops of water can carve a path through something as hard as stone. And that's true about the world in general, right? So if you view yourself as a drop of water or a stream of water over time, and you find that dent in the universe you want to make, and you continue to persist and push on it, eventually you can wear away at it and make a change. It's great if you can get excited about other people's ideas, right? If you can get excited about their ideas and they can get excited about your ideas, you can be force multipliers for each other and you can get a lot done. Here's one that's really important. A lot of the questions, I think, it's hard for us who've been way down in the weeds on stuff and working on these detailed experiments to then say, well, how does this translate to issues of national and international importance? Well, the way that it translates is just like this, right? If you can be specific about what you want to do, how you want to do it, why now is the time to do it, who needs to be a part of the effort, who could stop you, who can help you, and by when, you can lay out a pretty decent roadmap for at least, what the thing is and why it's possible. And you still have to convince people it should happen, but you're off to a good start. Intellectual arbitrage is important, right? So if you can see a tactic, some technique that someone's used. We do this all the time in the sciences, take a technique from one field over to another field. That's useful in the rest of the world as well. Take a technique or a tactic from the private sector and bring it over to the public sector. Take something that you see from the public sector to the private sector. Super important to have a wide range of relationships. And, these are good rules of thumb for what those relationships should be based on. Reciprocity, right? I help you, you help me. It's okay to be transactional. Try not to be too gross about it, but it's okay to be transactional. Thank you for helping me. Can I do anything to help you, right? In fact, a great piece of advice is the next time you go ask someone for help, at the end of the conversation, just straight up say, thank you very much. Is there anything I can do to help you? You'll be surprised at how valuable that is when you do that. And it's a great way to get people on your side. Trust and mutual understanding are important. It's great if you can be willing to let others take the credit. Bill Bonvillian is a master of this kind of stuff. So many things he's made happen in the world that I'm sure I don't even know he was responsible for, but that's because he's willing to let others take the credit. Here's a great one, right? And this is just good advice for your own PhD advisor. If you want someone to help you, make it as easy as possible. So, for example, if you want your PhD advisor to write you a letter of recommendation, write the letter of recommendation, okay? And say, would you write the letter of recommendation? Here is a draft that gives you a starting point, and you can do what you want with it. There are a million iterations of this, and it's totally fine, and powerful, important people will appreciate it if you make it easy like that. You can do the same thing for emails, right? Would you send an email to so-and-so to ask them this? I'll draft it for you, right? You start drafting emails for your boss. The boss is going to love you, and you're going to feel very like you're getting a lot of stuff done. Okay, so let me see. I'm going to skip to one here. Fanatical about identifying and recruiting talent. So find those pockets of great people, find where they are, go out and get them on your side, right? This is, just to be transparent about it, this is one of the reasons why I'm here. I know you all this is a pocket of talent, right? And I want you to see the world the way that I do, and I want you to be inspired to go out and do things that I think are important. So find ways to identify and recruit talent all throughout your career. Tom Sawyer and the White Picket Fence, influence without authority. There's a lot of times you can get stuff done. You don't have to make someone do it if you can convince them they can do it. Here's a really important one. Don't let the urgent drive out the important. So at least once a month, sit down and say, what are the things that are really important, the big picture things in my life, in the world, in the specific job that I have right now? Am I spending most of my time on those things, or am I just spending time on making sure that I'm at inbox 0, or which means making sure I don't have any unread emails, right? Or answering the most recent request from my advisor. And this is the hardest thing. If you can learn this skill when you're young, it'll be super valuable for you, because the older you get and the more responsibility you get, the more important it is, the more urgent things you will have to do every day, and the harder it'll be to do things. And then I think it's always important to think at the end at the beginning, right? What is the actual thing that you want to happen in the end? Think about it now. What is that thing you're building to? Now we do that we try to do it in our research projects, but you should be doing that in all of the things that you're working on. What is this thing? Where do I want to end up? What is the outcome I desire? Let's think about it at the very beginning. That way I can make sure that I can always work on the important. All right, that's all I have. I will say I have to leave in like an hour to go back to DC, but you can find me here or here, and I'm happy to chat with anybody. I will respond to your email as quickly as possible, usually within a day or two, and happy to meet for coffee or do phone calls or help you think about ideas, anything like that. So consider me a resource, and that's it. All right.
All right, I'm going to try to project. If you can't hear me, I don't know. I'm pretty loud. So I'm going to talk to you today just about some of my experiences in environmental policy, because I know that's an interest for some of you, or even if it's not, hopefully you'll be interested. And I'm going to frame this in why it's important that we oh, you need me to use a mic. Okay. I'll be respectful of that, and I will use the microphone. So why do we need to connect science and decision making? I mean, I think you're all here today because that's an interest of yours. And I think in the face of diverse and global challenges, such as those that we're facing right now, the need for this connection has never been greater. And a key role of science is to inform decisions, not necessarily dictate decisions. There are a lot of different things that play into decisions, right? Economics, social, cultural, et cetera. Science is only one piece of that, and that's important to keep in mind. But science can help society understand how the world works, how the world is changing, implications for people, likely consequences of different policy scenarios, and also, importantly, what are some viable solutions that can be put into place? So I come from straight-up research environment, right? I was an ecologist. I am an ecologist. But I did my undergrad research in the Caribbean studying coral diseases. It looks very glamorous. It was a lot of hard work being underwater for like 3 hours a day. And, we would often miss things like entire pods of dolphin that swam right by you. Well, I was measuring my sea fan, so I didn't see those dolphins. And then I did my graduate work studying rocky shorelines in Oregon and in New Zealand. So again, beautiful places to be, lots of hard work. But I actually really loved research. I loved everything about it. I loved getting my PhD. I loved my colleagues. I loved the inquiry process. And so I always thought I was going to go into academia. I then went and did a postdoc at the Florida State University Coastal and Marine Laboratory. And this is on the Gulf Coast, right around here in the Panhandle. And I was going to work on oysters and how drought impacts upstream were affecting oysters downstream. So my research site was Apalachicola Bay, right down here. And it's the end of a watershed that includes 3 states, Georgia, Alabama, and Florida. And it was in the middle of a very, very severe drought. And so there were crazy water wars happening. Those crazy water wars are still happening. In fact, just last week, the Supreme Court agreed to hear this case. So this has been going on for decades, but it continues to be timely, especially as drought becomes more prevalent and resources become more limited. And one issue is that the metropolitan Atlanta region is growing very fast, has a lot of water demands. So you have sort of a situation where it's municipal needs versus an ecosystem at the end of the watershed. And so all kinds of interesting science policy discussions can be had about that. But here I was, in my rusted out trailer doing tank experiments on salinity and temperature and seeing what happened to the oysters. And, the fishery around me was basically collapsing. And I would be out on the water working with staff at the National Estuarine Research Reserve in the Bay. And I would see the oystermen and I would chat with them. And I was like, okay, I can collect all the data in the world, and I felt like I couldn't help them. And I also couldn't fix the water war. And so I felt a little bit disconnected, I guess, from sort of what I was doing and what my goals were. And so I started volunteering as a science advisor for the fishery, just to, both hear what they were seeing and also kind of talk to them about what we knew about what was happening. And I also went to pursue sustainable seafood certification for that particular fishery because it was very sustainably harvested and had been for many generations. And so those were a few ways that I felt like I just wanted to engage. I wanted to engage a little bit more than I had been. And so I applied for faculty positions, I applied for other postdocs, I applied for grants, and honestly on a whim, because I met some people at a climate conference for recent PhDs, and I'm an extrovert, so I liked talking to them, and the conference was called Discourse, and 2 people were doing a AAAS policy fellowship, and I was like, well, tell me more about that, and they were like, it is discourse on crack, and I was like, that sounds awesome. And so I applied. I actually both got offered a faculty position and the fellowship on the same day, which was a very interesting career point for me. And what I ended up doing was accepting the fellowship and delaying my decision on the faculty position for a year. They were very generous with me. And when I went back to the campus to talk to them, I realized that at this moment in my life, I was much more excited about this world and what I was doing, and I felt like I still had a lot to learn. And so I turned it down and stuck with this path and have been on it ever since. But the fellowship, they call the fellows the mafia. It's a very rich group of people, lots of alumni, thousands of people have been in this program since the 70s. And the goals, you'll hear more about it in the fellowship panel, but anyway, are to connect science and society through providing knowledge to support the development of informed policies, and also to enhance scientists' understanding of key decision needs. So I had to buy my first suit, and we got this amazing orientation, and it was just this really great experience. And where I landed was at NOAA, the National Oceanic and Atmospheric Administration. This is an agency within the Department of Commerce, which may not be intuitive. That's a whole other story. But it is a really cool agency, and it is one that I had actually engaged with in my research career. Both, my postdoc work was in a NOAA National Estuarine Research Reserve. My undergrad research was in the Florida Keys National Marine Sanctuary, which was, run by NOAA. So I had familiarity with NOAA, but I had never worked at NOAA before. And when I was interviewing, I interviewed in the NOAA Climate Program office, and they said, well, we need someone to be our ecosystem expert. And I was like, you guys want me to be your ecosystem expert? Okay, right? And it was just sort of I can do this. Even though they were in NOAA, they had people with much more expertise in things like global climate modeling and other things like that. They didn't actually have someone who could build those bridges across the agency and work with the parts of NOAA that manage coasts, manage fisheries, et cetera. So it was really a dream gig, and I did the fellowship for 2 years and then stayed on as a federal employee. And so again, we do work at kind of global to local scales. So we do, NOAA does a lot of global climate modeling. They support a lot of global observations. We do work like developing decision support tools around sea level rise so that coastal communities can understand where they're vulnerable. We do aerial imagery of places impacted by hurricanes, like this example in Sandy, and recently with the storms in the Caribbean and in Texas. And so, anyway, it's a wonderful place to work. My office, the climate office, was generous enough to loan me to the White House for what was supposed to be a year. It's basically like a sabbatical. We call it a detail. And I ended up staying for 3 because it was such a great gig. And, Robbie talked a lot more about what it was like to work there. But again, my portfolio was largely around climate resilience and kind of all the policies that we could put into place to protect communities from the impacts of climate change that we know are happening. I came back in January at the transition and came back to the climate office, realized that I had sort of, that I wanted a change of scenery. I had grown leadership skills and supervisory skills, and so I pursued a new position in the Office for Coastal Management, which is in the Ocean Service at NOAA, and I'll talk about that more in just a second. So no good government talk leaves out an org chart. So here's NOAA, and this looks really big. This is our headquarters organization, but actually this is, like people-wise, this is a very small amount of people. So these are the people who sit downtown. They do things like communications, legislative affairs, et cetera. We have only recently kind of started getting political folks in place at NOAA. We had maybe one or two early on. We now have acting, so we have an assistant secretary who's been confirmed, and he's now acting as the head of NOAA. He comes to us from the Navy. He was the oceanographer of the Navy and brings a wealth of experience in oceans and coasts and policy in general. And then we have a couple folks, including the potential administrator for NOAA, who've been nominated but not yet confirmed. So we're in a little bit of a limbo while we wait to see who, see if and when these folks get confirmed, and they will then be running our agency. But for now, we have an acting head of NOAA who is a political appointee who has been confirmed. And then here's where the vast majority of people work. But I just wanted to put this up here to sort of show the diversity of what we do. We have a fisheries service that manages all the fish in the United States waters. We have the ocean service where I work. We do ocean monitoring. We do coastal and ocean research, coastal management. We have a satellite service. So NOAA helps develop satellites for things like weather information and climate information. We have a research line. That's where the Climate Program Office sits. We also run the National Weather Service, so a lot of people only know NOAA through the National Weather Service and don't even realize that the National Weather Service is part of NOAA. And then we have the Office of Marine and Aviation Operations, and they do things like fly our hurricane hunter planes and captain our research vessels. So my office, the Office for Coastal Management, is actually a really big office as far as federal offices go. We have over 200 federal employees. We're very distributed all over the place because we manage coastlines. So we have, I supervise a team of about 15 people. Those people work in locations as diverse as the Great Lakes, the Commonwealth of Northern Marianas Islands, Mississippi and Alabama. They work everywhere. And so that has been fun to kind of have learn really how we work on the ground and have folks who are more service-oriented, who are working closely with the states and territories to implement our mandate, which is the Coastal Zone Management Act. And that act is from the 70s, but was very forward-looking in terms of how we in the United States can better manage our coastlines. It even, the act actually mandates that we require things like planning for sea level rise. And we have, so I lead the National Coastal Zone Management Program. And again, that supports the 34 states and territories that participate in this program. We give them funding through formula allotments where they get a certain amount of money based on their population and the length of their coastline to do things like public access projects, dune restoration, hazard resilience, and other things like that keep our coastlines safe and enjoyable for the American public. We also have competitive research grants in our program and other parts of our office. Our office includes the National Estuarine Research Reserve, so that was really neat for me, having worked in one, to now be able to work, again, at the national level in coordination with them. We have a coral reef conservation program that does a lot of coral reef research and coral conservation in the U.S. and internationally. And then we also have an effort called Digital Coast, which provides decision support tools for coastal communities. So my roles and responsibilities, again, I lead the Coastal Zone Management Program. I work very closely with the Coastal States Organization. These guys are not federal, but they represent the states. And so we can engage with them and kind of have shared priorities and conversations. And they're great to work with because, again, they have the membership is the state managers from the coastal states that we work with and support. I lead the team of NOAA liaisons to the state coastal management programs. So again, those folks who are based in the field. And then I also oversee our coastal resilience grants program, which is a competitive grants program. So altogether, my portfolio is about an $85 million portfolio. $70 million of that is the funding to the states, and $15 million of that is the coastal resilience grants program. So what's a typical day like? So, I used to do this kind of stuff, right? I'd go out on the coast, I would engage with students. I don't get to do that very much anymore. I did, with a few exceptions, I was able to go to Hawaii a couple of weeks ago for a conference, and we actually got to snorkel, and it was super exciting because usually I'm in a cubicle. So I've gone from that world to more of this world, right, where I have a lot of meetings. Lots and lots and lots of meetings, lots of discussions about different approaches we might want to take on certain policies or decisions or events. And, sometimes it feels a little bit like this, like you're living in office space. Although I love my colleagues. They're really, really smart, talented people who care deeply about the work that they do. And at the end of the day, sometimes I just feel like this, right? Like, I've been in 9 meetings, okay, and then I had, 1 hour at the end of the day to try to catch up on 150 emails or whatever that might be. But at least my office is highly interactive, and that's something that I really enjoy. And I think, whether or not you're in academia, if you like to collaborate, this is a good type of environment. So what I've worked on, I'm throwing this up here just kind of like why Robbie did, just to show you some of the diversity of efforts that I've been involved in my science policy career so far. So, lots of climate resilience work, national climate assessment, ocean stuff, Hurricane Sandy rebuilding. I'm also involved again in hurricane recovery for the most recent storms that have come through. At the White House, I led a lot of the resilience work under the Climate Action Plan and led the White House Climate Education and Literacy Initiative, and I'm now, in my new role, leading a strategic planning process for the National Coastal Zone Management Program. So I think, I wanted to focus a little bit on what some of the challenges are for early career scientists who might want to engage in science policy. I think that there is still some perception in academia. It's, dependent on your advisor and things like that. But that time spent engaging with decision makers or outside of the lab is like a distraction or a detraction from your core job, which is to do your research. And that there are also, in general, a lack of training opportunities in communicating with policymakers, especially for early career scientists. We see more of these for senior scientists, and it would be great if we had more of these at all career stages. There's also, there could be a perception that young scientists aren't as credible as senior scientists, or even young scientists themselves might feel like they're not credible, and that can be a barrier to engagement. And then there is, in general, again, it depends on the institution, but a misalignment of incentives and values between academia, where you're really, a lot of merit is placed on your publications and your grant funding and things like that, versus the policy arena, where it's like relationship building and communication. And the number of memos that any of us have written up here that have our name on it, right? If it's a high-level decision memo for the president or something like that, like, your name is rarely on things that you do. And that's just something that, you never, you can't get hung up about that, because it's just the way that environment works. And a lot of what you're judged on is your ability to work with people, the quality of your writing, things like that, which, again, translate both worlds, academic and not, but it's just a different culture. But I do think there are a lot of benefits of engaging early. I think that early engagement can improve communication skills of scientists early in their careers, and can also enhance scientists' understanding of information needs. So again, when I was working in Florida, it was really valuable for me to talk to the oystermen and better understand what they were seeing on the water, because they're out there every single day. So they had a lot of anecdotal observations that I, as one individual, would not have been able to collect in my as a scientist, those actually inform the development of my experiments, for example. And you can ensure from the outset of a project that the science you do will be useful and relevant if you engage with decision makers right up front. I should also say, when I say decision makers, I don't necessarily mean like the president or members of Congress. I mean, whoever it is, a state wildlife refuge manager or somebody who might use a product that you're trying to develop. So in terms of experiences that you can gain to kind of get into this world a little bit more, fellowships are great, and you'll hear more about that in the next panel. Communication and media training workshops, there are some, for example, through AAAS and an organization called Compass, but there are options out there, including those that are open to early career folks. If you want to keep your day job and you really like doing research, I think that's great. Like, there's a lot of need for people who want to continue in research but be useful to society. So, if you're a student and you're interested in dabbling, you can take courses in policy like Robbie did. You can conduct informational interviews with people whose career paths you're interested in. I didn't know what that meant when I was a student. I was like, what do you mean informational interviews? Basically, like, go have coffee with someone or have a phone call with someone whose career looks interesting to you. And that's something that's been really beneficial to me. And just learn a little bit more about their world. And then also do things like give community talks or go into schools, practice analogies if you're trying to explain something complex. Basically, just figure out how to translate science for non-scientific audiences. You can do things like provide input during public comment periods on federal reports and draft policies. So the vast majority of what the federal government does at some point will go out through a public comment process. Any American can comment on that, and I think it would be great to see more comments coming from students and universities, on draft policies or technical reports or documents. So the Federal Register notice is like the super fun way that the government puts those out. You can keep an eye on that for things in your area of interest. Once you're a little bit farther along in your career, you can serve on advisory boards and review panels for agencies or like the National Research Council. And then again, at any career stage, you can collaborate with managers and decision makers on projects. And importantly, I think conducting work that's of high relevance to the policy community and disseminating the findings broadly in formats that are usable by non-scientists. Most folks, including myself, don't spend a lot of time reading peer-reviewed papers anymore. I know how to do that, right? I've spent a lot of time doing that in my career. But these days, I tend to read abstracts, right? Or I tend to read another type of summary document for whatever it is. And so finding ways to translate your language into something that would be usable by someone on the Hill or someone in an agency is very valuable. But so for me, I would say the bottom line is that you're never too junior. These kids might be a little too junior to like sit in the room with the president, but I had an experience where I didn't get a position I interviewed in that I thought I had interviewed well for. This is a number of years ago, but they told me it was because they thought I couldn't hold my own in a room of high-level individuals. And the next year I was at the White House, right? And I was like, actually I can, And so I think, just don't let that stuff get you down if that happens to you, because you can, and you will. And I appreciate the opportunity to be here today, and feel free to reach out to me. I'll be here all day into the evening. But yeah, if you ever want to talk career stuff or anything, I'm happy to chat.
Hi, everyone. So Robbie and Laura have done an excellent job setting the stage, and I think I'll be able to fly through some of my content and get us to the Q&A. But thanks again to Michaela and Courtney and the organizing committee for inviting us here. It's been a great opportunity. And we don't get to do this too often, so it's fun to connect with students and be back on a university campus. So my name is Megan. I am a staff associate for strategic engagements at the National Science Foundation in the Directorate for Computer and Information Science and Engineering. So that's SISE, as we call it. We love acronyms in the government. And I'll talk a bit about my role, but first, let's go forward. So I'll start with a little bit of the origin and mission. Bill provided a fantastic background and history on the evolution and origin of NSF. I'll provide a little bit of my career pathway and how I ended up where I am, what NSF's daily operations are, really what the bread and butter of the agency is, our structure and the job opportunities for PhDs. What is NSF's strategic direction looking forward, some of the director's initiatives that she's put forward. I'll have a similar slide that both Laura and Robbie had of exactly what do I do on a daily basis, and then where NSF fits in the landscape. Probably the realizing your assets. We've doubled down on that, so I think you guys have heard that. Okay, as mentioned today, I think many of you captured this, that NSF was established in 1950. The mission is to promote the progress of science, to advance national health, prosperity, and welfare, to secure national defense. And I've gotten a few questions throughout the day about whether we do, what is our political, do we have a political appointee? Our director is a political appointee. She was appointed during the Obama administration, and her term actually transitions between the administrations. So she will stay. The president does have the authority to remove her or replace her, but unless something goes wrong, that's not anticipated at this point, and we anticipate that she'll stay through the end of her term. There's also the National Science Board, which helps determine the priorities for the agency, and a number of councils, advisory councils, and committees, which Matt described, who help set the strategy for the agency. And our mission really is to initiate and support basic science research at colleges and universities across the country. I don't know why I'm struggling with this so much. All right, this is a short video. It's a minute. It's a little over a minute. Just really diving in on what the NSF does. As a graduate student, and as an undergraduate, I was supported by NSF, but I didn't really understand the bigger picture. So I thought this might be interesting and engaging to see the bigger picture. I think in the back you have to click play. In the booth, page 1212. Can you click bottom corner, yeah. It should have sound.
This is about discovery.
We had the sound working this morning.
Changing the way we live.
Did you ever use a CD, cell phone, barcode, that thing they call the internet?
Maybe a touchscreen, LED light. This is about discovery.
Pushing the edge of the known.
Changing the way we live.
Did you ever use a CD, cell phone, barcode, that thing they call the internet?
Maybe a touchscreen, LED lights, a web browser, GPS.
Ever get an MRI, do a Google search, check a weather forecast?
Every one of those things was improved on or made possible by fundamental research supported by the National Science Foundation.
And there's also 3D printing, laser eye surgery, safer cars.
New biomedical tools, improved disaster preparedness.
Even disease-resistant bees.
Today, NSF supports people and places to develop tomorrow's scientists and engineers.
And create new knowledge in fields from A to Z.
To help us understand our world, solve societal challenges, spur innovation, and improve our lives.
The National Science Foundation supports fundamental research,
insights,
ideas,
breakthroughs
that ultimately create jobs and help drive our economy,
enhance our nation's security,
and advance our knowledge to keep us a global leader.
What really causes economic growth is it's always innovation. So how do we get more of it? We invest in basic research. And that's as simple as that.
It's as simple as that. And you guys, the people doing the research, right? That's a huge portion of NSF's budget is in the people. So we can thank our Office of Legislative and Public Affairs for that beautiful video. So this is my career path. So I started with NSF, the background, and then now I'll turn to my pathway, because NSF has kind of been there along the way with me. And it's part of my experience through funding is what led me to want to pursue an opportunity at NSF. So I went to Vanderbilt University for my undergrad degree. I did research when I was at Vandy. I did biomaterials research, and I also did STEM education research. So I had an REU, research experience for undergraduates, and also there was an RET associated with it, Research Experience for Teachers. And this is a type of a grant mechanism that NSF uses to support undergraduates in doing research. And that research was in new K-12 engineering curriculum development. And I worked with local Nashville teachers to help them develop new curriculum to roll out in their classrooms. And then we did evaluation of the curriculum to quantify the benefits. So I became really interested in STEM education through that. And I've always kind of kept that as a part of my portfolio throughout my research, and even today. So I decided to go straight into graduate school. I wanted to do research. So I was specifically interested in one very narrow research area. It was a health area that affected me, so I knew the clinical scenario, and I thought that research really was a new opportunity to kind of pursue that. So I went to UC Davis, which was the premier institution to study this, and fortunately was awarded a GRFP, the Graduate Research Fellowship Program. I got in my second year a grant to support my research. So I knew NSF in the context of money, but I didn't really know how the decisions were made beyond the fact that I submitted that grant, I drafted that grant, right? I knew that, but I didn't really know how the decisions were made. And I also, when I was at UC Davis, we had this program where you could get sort of like a minor to your PhD. It was called a designated emphasis, and I had a designated emphasis in biotechnology. So I was interested in industry, and as part of that, you had to do an internship. So I took an internship opportunity at VSP Global, which is a giant eye insurance company. So many people have VSP. It's almost a quarter of the nation has VSP insurance, which is crazy for eye insurance. They had just started this innovation lab in Sacramento, not too far from Davis, and they were working on a brand new wearable product. They had previously been working with Google, and the Google Glass product went off the market, and they wanted to do their own wearable. So this is really how I made this transition to computer science and electrical engineering. I went from doing tissue engineering, I studied cartilage regeneration, to working on circuit boards and working with electrical engineers and computer scientists, software developers, designers also. And I think that's like one of the key takeaways in my career my career pathway was my ability to work across these disciplines and to gather these new skills along the way. And that's how I transitioned through the AAAS Fellowship. I came in to NSF in the Computer and Information Science and Engineering Directorate. And I really used those skills that I acquired collaborating with electrical engineers and computer scientists and talking across the disciplines. There was an interesting kind of dichotomy at VSP in our it was this very small group, only about 8 engineers. And I was really the only one that would speak across literally the electrical engineers and firmware guys were upstairs. I sat with them upstairs. The software developers sat downstairs. And it was like a world apart. But I felt very comfortable working among both teams. That was something I think, gathered that skill during my PhD, so as a biomedical engineer. So, and that's now what I do at NSF. I spend a lot of my time working across disciplines and building new interdisciplinary programs. All right. So let's all get into the nitty-gritty about my job at NSF in a little bit. So NSF, our mission is to support research, right? So the main function is proposal processing. These numbers, this is a couple years old, but just to give you a sense, the input over here, 50,000 proposals in a single year, 38,000 reviewers either come or review remotely these proposals. 233,000 reviews are submitted of proposals. So it's crazy numbers, and the proposal pressures are only continuing to rise. At the end of the day, that means about 10,800 awards funded, nearly 2,000 institutions getting awards, nearly 300,000 researchers, postdoctoral fellows, trainees, all supported. 47,800 students impacted. That's pretty remarkable. So it's and some of the workforce development, the research itself, of course, the outputs of the research are also a metric to quantify. So what does the merit review process look like? Proposals the announcements are posted. They're posted for 90 days. They're posted by NSF's website. We push announcements every time a new solicitation is released. A solicitation is a way we call for proposals. And then proposals are submitted, and then the review process begins. And this is the main function of our program officers. So our program officers, their responsibility is to identify reviewers. They group the proposals by theme. They identify reviewers. And then they hold review panels, and the proposals are reviewed and ranked and evaluated. And then awards are made. It's a 30-day process of actually, once the award decision is made, actually moving the money. And the two, I think probably most people know this, the two merit review criteria for NSF, intellectual merit and broader impacts. I could spend a lot of time on that. Maybe we'll save that for Q&A. But those are the two merit review criteria. This is the computer science directorate, specifically by the numbers. Our budget is nearly almost $1,934,000,000 in 2016, 8,000 proposals coming into the SIZE directorate alone, 372 panels. So if you think of a panel is a 2-day process. Reviewers fly into NSF. That's what we churn. That's the majority of our workload. So 372 panels, that's a lot of panels. That's a lot of work. Again, you can follow these numbers. This is breaking down the numbers I just showed you by size. So here's another org chart for NSF. I just want to show you, so NSF is divided up by scientific directorate. There are 7 directorates: computer science, I won't list them all, but computer science, math and physical science, biology, education and human resources, engineering. That's the gist. This is our director. This is our director, France Cordova. And there's also a political position below her, which has been vacant for several years. But if you think about this organizationally within the federal government, she reports essentially to the president. So she's the top of the agency. We're an independent federal agency. And then this guy down here, Jim Caros, is my boss. His boss. He's 2 people away from me. And I'll show you that in a second. But he leads the directorate for computer science directorate. Okay, one more. I couldn't resist another org chart. This is size. And so Jim, when Robbie was talking about staffing people, and we always are doing something for the main guy. So Jim's job is to always ensure that the director of the agency knows everything she needs to know about computer science. Erwin, his job is to make sure Jim has every piece of detail he needs to do that. And then my job is to make sure that Erwin and all of his support staff across the divisions have what they need. And my job spans a bunch of different things and a range of topics, but this role, this staff associate for strategic engagements, is really to align us with the various objectives that SIZE has, to set our priorities and provide the background, the data, the new partnerships, whatever needs to be done to realize the strategy. I don't think we really have a ton of time to spend on this. I will share that the director of the agency, France, announced 10 big ideas for future investments. These are thematic areas that we see as forward-looking key priorities for the agency and for science looking forward. I encourage everyone to check out, there's a video about the 10 big ideas. One that I work on personally is the work at the human technology frontier. This is thinking about the impact of new technology development, AI, machine learning, robotics, advanced manufacturing on job prospects in the future, and how individuals interact with their job or with technology in their jobs, what technology will enable us to do in the future, how do we make sure that technology is not simply replacing people. But and then convergence research, this is another one that I've worked on, this is a process idea, but convergence is thinking about interdisciplinary research spanning various disciplines. How do we ensure that students are trained and prepared to speak across multiple disciplines and ensure that's really where the frontiers are. Every single one of these 10 big ideas spans multiple disciplines. So the convergence is the idea of pursuing research that spans multiple disciplines to help realize these future research areas. Way too many details on here. The idea is simply, this is what exactly I do. I'm just going to walk through and give you one concrete example in each of the areas, but don't try to process all this. They're just graphics to show the theme. So industrial partnership development. In SIZE, we have worked with companies in the past, for example, Intel, to co-fund research with us. So they match our funds in an area that's of interest to both of us. Part of my job is developing new partnerships and also providing data about our ongoing partnerships that, for example, the director might be interested in knowing or need to know when communicating with OMB about our budget. International partnerships. For example, we have long partnered with the Japan Science and Technology Agency. Japan has a lot of strengths in AI research, so we work with them. We support our NSF researchers to collaborate with JST researchers and to leverage their skills and expertise there and to help bolster our ecosystem looking forward. Congressional activities. There was a hearing 2 weeks ago that Jim, the boss of SIZE, the head of SIZE, was asked to testify on quantum computing. So I worked with our experts in SIZE who study quantum to help provide Jim with the information and the storyline of his testimony to go forward and testify to Congress with that. That included pulling data about our investments in quantum, for example. I'm trying to move through this fast. Interagency coordination. We talked about some of these strategic plans that OSTP in the last administration released. I helped to draft one of these. This was a Smart Cities strategic plan that included all of the agencies whose logos are up there in the top right corner, and I'm now the co-chair of that group. Program development, when there is, so aligned with this Smart Cities effort that last year's OSTP, or last administration's OSTP put forward, we developed a program called Smart and Connected Communities, and I helped to develop the agenda for that new program. We also work with, from the bottom up in setting research priorities, I also work with, down here, this is an example of a workshop that NSF supported. We work with the research community to hear from them what they think the research priorities should be. And that helps inform the new programs that do come out. Proposal processing, part of my job is also in actually running the panels and processing proposals that the program officers exclusively do. And then priority setting, so I mentioned this, the work at the human technology frontier. Again, working across all of NSF to help determine what exactly that means when the director goes and speaks about it and engages with that OMB, for example, on that topic. We talked a lot about this spectrum, the science for policy, policy for science. Just to reiterate, NSF is down here. We work on the funding, the capacity building, training students to enable new science to be done with funds that are allocated by Congress. I think we've gone over this pretty sufficiently. Some of the things that I found valuable in my training and that I've taken forward to the policy landscape, understanding the startup landscape, entrepreneurship, working in outside of your specific research area when you have the opportunity to, I think enables you to develop skills that you can take forward. So it was an invaluable experience for me when I went to industry. I did that internship, and then I was hired after the internship, and that's really helped inform my work in government. And now I'm very happy to be in government, but I'm glad that those skills that I acquired in industry before. Take on leadership roles whenever you have the opportunity to. I think during my PhD, we had a lot of animal studies. We worked with human clinicians, veterinary surgeons. We worked with pathologists, mechanical engineers, statisticians. I think developing the ability to lead teams across disciplines and sectors is incredibly valuable. That's what many of our programs going forward at NSF are pulling on, and the ability to think and lead across those disciplines is very important in today's world. Mentoring students. I think being a good manager and developing the skills to lead individuals is is really important. And identifying good talent and keeping good talent is key to everyone's success, I think, as individuals. Building a network of colleagues, informational interviews. It's sometimes intimidating, but do it as best you can. Getting those meetings and taking advantage when you have the opportunity is important. Okay. All right, I think we'll stop there. That's what I wanted to share. These are some of SCI's different media outreach methods. But you can also email me. I'd be happy. I have cards. And yeah, I guess we'll switch over to a little panel action. Yeah.